We are going to be learning rules on how to take derivatives. You probably already seen them. Maybe you went to Khan Academy, or maybe you saw some Delta Math videos or some YouTube videos. Don't become a robot. Understand that these happen because of the properties associated with when we do the limits. Like, Chop, what are you talking about? Okay. First, a constant. So the derivative of every constant is 0. Why? Well, look, guys, if I told you to graph y equals 5, y equals 10, y equals 100, all of those are horizontal lines. All of them. Y equals 5, y equals 10, y equals 100. What's the slope of a horizontal line? 0. So you're not shocked. So if you take a derivative of a constant, it's always 0. So you can say y prime equals 0. You can say dy dx equals 0. It doesn't matter how you say it. You can even go d dx of your y here is 0. Those are all different ways that you can write your notation for the derivative. Are we okay? Nothing crazy, right? Okay. I actually prefer if this were to be an f of x and an d dx of f of x, but no big deal. We're still the same. All right. This is called the power rule. That's for a reason. Do you guys know what this says? Like, can you interpret what that means? Okay. Let me tell you what the derivative of all. Let's do one longhand, one more last time. This will probably be the last time we do it like this. So if I were to tell you what's the derivative of x squared, you would tell me f prime of x equals limit as h approaches 0 of f of x plus h minus f of x all over h. Do you remember that? And then you would say, well, f of x is x squared. I need f of x plus h. F of x plus h, wherever you have whatever this is, that's your argument here. So x plus h close it squared. X times x times h is xh. How many of those are you going to have? 2xh. And then h times h squared. So here it is. F prime of x equals limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. Are we still okay? What's going to cancel out? Oh yeah, 0 out. What can I factor out? H. So I have limit as h approaches 0, h factored out, 2x plus h, close it all over h. Now what cancels? And then h is approaching 0, so I just have, so f prime of this is nothing more than 2x. Cool or not cool? Okay. So let me show you what these derivatives are. If we were to do that with this one, letter B, you would get f prime equals 7x to the 6th power. If I would do that with letter C, you would get f prime of x equals negative 5x to the negative 6th power.
Where do you have the 6 from?
Yeah, I'm just giving you the answer.
But I'm like, where did you get the answer?
Yeah, I'm just giving you the answer because we're going to talk about that right now. If I turn this into an exponent and I tell you what's the derivative of that, bless you, you're going to get 1/2 x to the negative 1/2, which is 1 over 2 square root of x. Hopefully you remember that derivative, but if you don't, that's okay. How did I get them so fast? Just like Ms. Cruz said, bless you squared, bless you cubed. Just like Ms. Cruz said, I got them all from this expression. Here's what is this rule called? It's called the power rule. And it doesn't matter, it says for positive integers, it doesn't matter for anything raised to the power n, as long as n is a real number. So how do you take the derivative? How do you use it? You bring the n down. See, we brought it down. And then you subtract 1 from the exponent. So that's how what is that rule called? Power rule. So look at this problem that we just had right now that we did the power rule. F of x equals x squared. So f prime, bring the number down, 2, and then subtract 1 from the exponent. Oh, look, that's what we got, 2x. So that's what we did for this. We brought the number down, 7, and then we subtract 1 from the exponent. I brought this exponent down, negative 5, and I subtracted 1 from the exponent. Do you guys see what we're doing? No, Henderson? If I bring this 1/2 down, here's the 1/2, and I'm going to subtract 1 from the 1/2, and I get negative 1/2. What 1? There's no 1. Oh, from the formula here. From this formula, n minus 1. I was like, where's the 1? I don't know what you're talking about. All I did was use a rule. It's called the power rule. It's just a definition. Do not become a robot. There's a reason why this works. Why does it work? Because all these limit expressions, every time you take a derivative of a polynomial, it decreases by 1 degree all the time. What's up?
Will we like see the certain way? Will we see how a certain equation is set up, and then that's how we know what rule to use?
If it's a polynomial, you're going to be using power rule. And today, all you're doing is power rule. We're not going to learn anything else other than power rule. Hit me.
Hashtag C-simple. Hashtag it's too cold.
Oh, that's going to be the next hashtag. It's already warming up, though. I'm already getting hot. It's because this laptop throws too much heat. It's recording and it's radiating heat. I can feel the wind blowing right here. Well, it's because it records. It can't help it. That's the only way it cools off. All right. Is this making sense, guys? All I'm doing is using a formula. That is all we're doing. So go turn the page. All this is telling you is that you can leave the constant alone. So look, this is the constant multiple rule. It's not even worthy. Leave the constant alone and then take the derivative. That's all it's saying. So we can, so let's do it. Let's do it the way they tell us to do it. Solve for y prime. Y prime equals, leave the constant alone, 5. What's the derivative of x squared? 2x. Good job. What's 5 times 2?
10.
So I'm just going to write 10x. See?
So you take the derivative of, and you do that one more time.
Well, we're going to do it 4 more times.
Okay, I mean.
Here we go. I'm going to go slow. Y prime, leave the 7 alone. What's the derivative of x cubed? 3x squared. What's 7 times 3? 21x squared.
21. Squared. Bro, what's so funny about numbers?
It's squared. It's not cubed. Are we okay?
Oh, so we still subtract 4 like we did in the last one?
Yes, this is all power rule.
I see.
Negative 20, parenthesis. What's the derivative of x to the negative 5? Negative 5x to the negative. There it is. Let's simplify it. Negative 20 times negative 5. 100 x to the negative 6. Are we okay?
Wait, can I do this one?
Yes.
Alright, let me show you right now. Alright, chat. When did I
Hey, guys, no fighting.
She low-key hit you up. You're actually funny today.
All right. I want to make a comment. You do not always have to do this, guys. You can be fast. How do you be fast? You can just go, you bring the 2 down. What's 5 times 2? 10, and then subtract. See? You don't have, look, what's 7 times 3? 21, and then x squared. Do you guys see what we're doing? Y prime. Negative 20 times negative 5. See? You don't have to go, you don't have to do it in 2 if you want to do it in 2 steps all the time, that's fine. But how to do it fast? I had to, look at this. I had to turn it first into an exponent using your algebra. What is half times 8? 4. X to the negative half, which means square root of x in the denominator.
Wait, huh?
Guys, come on, guys. X to the negative half is 1 over square root of x. From your algebra days, guys. No, we're good. But now you know, in case you didn't know.
4. Right.
The x to the negative half, 1 over x to the half, x to the half.
Why don't we divide that to something?
What? I didn't divide anything. What are you talking about? Ask me, miss.
divided by square root of x. Right?
4 divided by square root of x because of the negative exponent. Oh, well, because I don't know what you were talking about. This is 8 squared of x. They have it in terms of square root or radical, so they probably want it in terms of radical again. You could have left it as 4x to the negative half, but because they have it right here, 8 squared of x, I wrote it in terms of square root of x. So 4 over square root of x. Does that make sense? All right. All we're doing is power rule, guys. We're not doing anything else. So all this is saying, look, I have something plus or minus something, and you're just taking the derivative of that plus or minus the derivative of the other. Bless you. So what does that mean? Look, we have one right here. This means take the derivative of p with respect to t. So I'm going to go dp dt equals, what's the derivative of t cubed? Yep. Plus, what's the derivative of 6t squared? What's the derivative of negative 5/3 t? Negative 5 over 3. Just negative 5 over 3. That's a linear line. Now the derivative of a constant? No. 0.
Oh, because yeah.
There it is. There's my derivative.
Wait, okay. 3t squared that makes sense. 6t squared.
I just took the derivative of 60 squared. So bring the 6 times 2, subtract 1 from the exponent.
And it would, the exponent would be 1.
Yeah.
6 times 2.
6 times 2 is 12.
I know, but like, could be multiple. Oh, this is funny.
Tell me, Houston. Tell me so I can.
You just do it again, but actually show this.
Wait, so you
Well, that is.
multiply the 6
All
and
right.
the square?
I guess I can do this if you want me to. dp dt of t cubed plus dp dt of 6t squared plus dp dt of negative 5/3 t plus dp dt of 16. Now this is not the way you want to do it because it will take forever if you keep doing it this way. But check it out. I'm taking the derivative of this with respect to t. What's the derivative of t cubed? 3t squared. All right. Take the 2, multiply by 6. What's that? 12. And then subtract 1 from the exponent. This one here plus a negative 5/3. It's a linear. So if you think about it, this is like negative 5/3 times 1. And then subtract 1, t to the 0. That's going to be 1. Or you can just think about it as a linear line. The derivative of a linear line is just that slope, just that number. And then this is a constant plus 0. So there it is, 3t squared
So if
plus
it was
12t.
like 6t cubed, it'd be like 12.
No, not 12.
12 times 6, whatever that is.
6 times 3. You said 60 cubed.
Yeah,
Yes.
so we had 6t cubed.
dp dt of 6t cubed. 6 times 3? What's that? 18t squared.
We just multiplied?
I'm just doing the power rule, miss. And bring the n down, x to the n minus 1. And yeah, you just multiply them just like we did here. Look. What do? We just multiplied them.
Okay, I think I get it.
I understand it now.
We're just doing this over and over again, guys. Don't be a robot. I could have written that part as ddt instead of dpdt. No big deal. Do we understand what's going on?
Yes. Wait,
Okay.
where did t go for the negative 5 over 3t?
It's a linear line, miss.
So the derivative is 0?
No.
No, it's just 5.
Yeah.
Because
You can use the power rule if you want. Look, 1 times negative 5/3 is negative 5/3, but then t to the 0, that's just 1.
Okay. I just remember that.
you don't got
All right, here we go, guys. Focus, focus. I have this function, and it wants to know, it says, does the curve have any horizontal tangents? If so, where? I do have horizontal tangents. I notice it's to the 4th power. So that probably looks something like this, or who knows, because of the x squared, right? So how do I find the horizontal tangents? I take a derivative, and I equal it to 0. So y prime equals the derivative of x to the fourth is 4x cubed minus the derivative of 2x squared is 4x, and the derivative of 2 is 0. I just took a derivative. This is my expression that tells me how my slopes behave, equal to 0. Are we still okay?
Yeah.
I'm going to factor out a 4x, x squared minus 1. And from there, I can see that I have three values where, 3x values where I have horizontal tangents. I have a horizontal tangent at x equals 0, and I have a horizontal tangent at x equals plus minus 1. Do you guys see that? If you guys don't like that, you can just expand it. 4x, x plus 1, x minus 1 equals 0. Oh, okay, I'll mention it later on because some of you guys sometimes do magic. Like, I don't know, sometimes you guys will say something like,
What are you talking about?
you guys will be like equals 15, and then some of you guys will say like 4x equals 15, x plus 3 equals 15. Guys, why? What? Like, that doesn't even make sense. Why would you do that? Like, this means something times something equals 15. That's why we always do it to 0. But I've seen you guys do this many times. This is nothing. This is not something. So equals 0. Well, if x equals 0, 0 times anything is 0. If x equals negative 1, it's 0. And if x equals 1, it's 0. I guess it's because you guys are a little robotic and you're used to saying this. X minus 1 is 0. X plus 1 is 0. 4x equals 0. But you can't do it if it equals a number. You can't do that because that means something times something is 15. You can't say 4x equals 15. It doesn't make any sense. That's not a thing.
So how did you know that those three values were the horizontal?
This is my derivative.
Right.
Derivative means instantaneous rate of change or tangent slope. And I equal it to 0. Horizontal tangents have a slope of 0. So at these values, I have a horizontal tangent. And we'll do a visual right now. What's up, Miss Kyle? Ask me, Kyle, and Houston. Ask me.
What happened to the four?
Y'all are so funny.
It doesn't matter.
What 4 are you talking about? The 4 in front of the x? This is 4 times x, miss. So 4 times what will give you a 0? 0.
I see.
All right. What was the original equation?
Y equals x to the fourth power minus 2x squared plus 2.
Check it out. At x equals negative 1, I have a horizontal tangent. Do you see that? At x equals 0, I have a horizontal tangent. And at x equals 1, I have a horizontal tangent. So there it is. It worked. Those are the values where you have horizontal tangents. Cool or not cool?
I have a question. Why is it plus and minus?
You don't, DeLeon, you could have just expanded it like this, miss. This is the difference of squares. You could have done 4x, x plus 1, x minus 1. Or you can go x squared minus 1 equals 0, x squared equals 1, square root, x equals plus minus 1. Negative 1 times negative 1 is 1, and positive 1 times positive 1 is 1. You know what I mean? Maybe the better route is this route. How are we feeling right now, guys? Yeah, we're just doing a whole bunch. If you don't practice, guys, you're going to get behind. Please make sure that you're practicing. All right, look at example 6. Find the tangents to the curve y equals x cubed plus x at the points where the slope is 4. What is the smallest slope of the curve? At what value of x does the curve have this slope? Okay, first let's answer the question. Let's answer the first question. It's asking many questions. So where is the slope 4? So what do I got to do? I got to take a what? Derivative. 3x squared. Does everyone know how I got the 3x squared? What's the derivative of x?
0.
No.
No, 1.
1. And I'm going to equal this to?
0.
No. 4. It wants to know, guys, the first question, it wants to know where the slope is 4, where my tangent slopes are 4. If I want to know where my tangent slopes are 4, set your expression of your derivative equal to 4. All right. Are we okay now?
Yes.
Okay, I'm just going to solve, guys. I'm going to minus 1. So 3x squared equals 3. So then from there, I can tell you that x has to equal plus minus 1. Are we okay so far? So at those values, you have a slope of 4, sorry. We're okay? All right, now let's do the next. It says, what is the smallest slope of the curve? So focus on this, 3x squared plus 1. What is the smallest this expression will ever be? No, it will never be 0. 1. This is greater than equal to 1. It will never be smaller than 1. Because, all right, guys, focus real quick. This is from algebra. This graph, if you were to graph it, it looks like this. The smallest it ever goes to is 1. For the 3x squared plus 1? Yeah. That's the smallest it ever goes, the smallest y value. The smallest y prime value you'll ever get is 1. That's the smallest it'll ever go, guys. It'll never go to 0. You'll never get this to equal 0. I mean, I guess if you do imaginary numbers. But you'll never get it to be 0. Does that make sense? All right. So that's the hard part, guys. That's the part where you're going to have to think a little bit. And it says, at what value of x does the curve have this slope? Okay, well, the smallest value is 1. And it happens when x is what? 0. So I'm going to write the smallest tangent slope for this curve, let me go ahead and write the expression out. For the curve y equals x cubed plus x is 1, comma, this occurs at x equals 0.
So why do we have to find the derivative if we could have just looked at, I guess, if we could have just looked at that one?
You can't just look at this because that's just an increasing function left to right. You have to look at your derivative because the derivative tells you your tangent slope. Yes.
If the first answer had been like x equals 3, does that mean the smallest slope of the curve would be less than 3?
Okay, say it again so I can understand.
You see how we got x equals plus or minus 1?
Yes.
If we had gotten like x equals 3, would that mean for the second question, what is the smallest slope of the curve? It would be 3.
No. If you would have gotten like x equals 3, that just tells me the slope at 3 is 4. Because remember I equaled this to 4? So I equaled it to 4, that's my tangent slope.
So then how do we know, how do we figure out that it will never be smaller than 1? Is that like the answer for all of them?
This expression, 3x squared plus 1, tells me my tangent slope at every x value. For all of them, all the tangents. My tangent will never be negative. It'll never be smaller than 1. As a matter of fact, the smallest it'll ever be is 1. Why? Because look, it doesn't matter what you put for x. I have a plus 1 here. So the smallest value you can put here is 0. 0 squared is 0. 0 times anything is 0. But 0 plus 1? 1. You can also look at your expression, your derivative graph. Look, here it is my derivative graph. The smallest y prime value is 1. All the values on top of that are bigger. So this graph, x cubed plus x, the smallest tangent slope we'll ever have is 1. That also tells me that this graph is increasing left to right. It's never decreasing. Why is it always increasing? Because my slope is always positive. So you're always going uphill. Kyle, you okay? You sure? Does this graph ever decrease? X cubed plus x? Why not? The slope is always positive, yeah. Hit me, guys. Hit me. What more questions have we got? Okay. How the heck do you find which one? Oh, example 7. Okay, well, you don't know product rule and you don't know quotient rule, so we just have to do algebra first. Relax. It's not even that bad. Notice the numerator is difference of squares. So you can rewrite this as x squared minus 25 over x. Are we still okay? I'm dividing by one term, which means you can do this. X squared over x minus 25 over x. Yes or no? X squared over x is just what? And let's rewrite this. If I bring that x up, I have not taken a derivative yet. Are we okay? Yeah, algebra is what's going to hurt us, guys, not calculus. Y prime equals, so now I'm taking a derivative. What's the derivative of x? 1. Good job. What's the derivative of negative 25x to the negative 1? Positive 25x to the negative 2. Rewriting it? I don't know. Maybe they want it. Well, actually, that's fine. I'm okay with that. Does that make sense? Okay, all we're doing is taking a derivative. Letter B. Can you take the derivative just like that? No. Turn it into an exponent. Good job. Here it is. Square root of x is the same thing as what? X to the what? No, just just 1/2. Plus the cube root of x is the same thing as x to the what? 1/3. Now we're ready to take a derivative. That's just y. So here it is. Y prime equals, what's the derivative of x to the 1/2? 1/2. Perfect. We're rookies. Let's leave it alone right there. Let's go to the next term. Plus, what's the derivative of x to the 1/3? 1/3 x negative 2/3. Just turn the denominator into 3/3. Turn the denominator. Whatever the denominator is, when you subtract 1, make it 3 minus 3/3. 1 minus 3, negative 2. You see that? Get the denominator. How do we feel? All right, here we go. Letter C. I'm just rewriting it. Y equals, I'm not taking a derivative yet. X to the negative 1. We're okay. Minus 3x to the negative 2. Plus 75x. Let me write it as dy dx. dy dx. All right. Tell me my first derivative. Negative 1. X to the negative 2. Perfect. What's the next one? Plus 6. X to the negative 3. What's the next one? Plus 75. Good job. We're getting it.
Okay.
We're kind of like just warming up, but you're putting it in the microwave right now. So we're not really cooking. We're just using electromagnetic waves. So we can use the power rule. If you're good, you don't have to. You can just take the derivative. But we're rookies right now. All right, let's do algebra. We don't, guys, this is right there. You don't know product rule. So let's put it together. This is x times x to the half plus 8x to the negative 1. I haven't done anything. I have not taken a derivative yet. Are we still okay? This is the same base as this. This is the power 1. So whenever you multiply, you just add the exponents. So this is x to the 3/2 plus 8x to the negative 1. If anything, there's more algebra than calculus. Calculus is just one little rule. Everything else is algebra. All right, you guys ready? Here we go. Y prime equals, what's the derivative? 3/2 x to the, 1/2. So you're just subtracting 1 from 3/2. So subtract 2/2. 1/2. And then what's the derivative of 8x to the negative 1? Minus 8x to the negative 2. Are we okay? We don't know chain rule yet. Maybe we might know Pascal's triangle to expand this, but if you don't know that, it's okay. I'm just doing algebra. X minus 5 times x minus 5 times x minus 5. That's what that power 3 means, right? I can do these two really fast. Right? All right. X times x is x squared. X times negative 5 is negative 5x, but I'm going to have how many of those? So it's going to be minus 10x. And then negative 5 times negative 5 is 25. And I still have one more x minus 5. If you know Pascal's triangle, go ahead. Use it. Not a big deal. All right. I still haven't taken the derivative yet. This is just still y equals x squared times x. X cubed. X squared times negative 5. Perfect. I've exhausted the x squared. You go to the next one. Negative 10x times x. Perfect. Negative 10x times negative 5 plus 50x. You've already exhausted everything for negative 10x. You go to the next one. 25 times x. 25 times negative 5. All right. Combine like terms. Here it is. Y equals. There's only one x cubed. I have a negative 5x squared. I have a negative 10x squared. That's going to be perfect. And I have a 50x and a 25x. That's going to be, and then minus 125. All right. You guys ready? Y prime. I'm going to put it in blue so we don't confuse it. What's the derivative of x cubed? 3x squared. What's the derivative of 15x squared? Perfect. There it is. What's the derivative of 75x? The derivative of 125?
0.
Good job. Don't be a robot. All we're doing is using the definition over and over. We're okay?
Yes.
Okay. I would like for you to recognize this, but it's okay if you don't. That formula there is for the difference of cubes. I'll write it up here. Yeah, I'll write it up here. A cubed minus B cubed equals A minus B. A squared plus AB plus B squared. That's a difference of cubes. If you did not recognize it, it's okay. You know what? Do I have room? Yeah, I'll put it over here. If you do not recognize it, it's okay. Look, check this out. X minus 2, x squared plus 2x plus, do they have plus 4? Yeah. You could have just done this. Look, x times x squared, x cubed. X times 2x, 2x squared. X times 4, 4x. We've exhausted the x. Go to the 2, negative 2. Negative 2 times x squared. Negative 2 times 2x. Negative 2 times positive 4. And look what happens. The 2x squares cancel out. See? Bam, bam. The 4x cancel out. Bam, bam. And you're just left with x cubed minus 8, which is, OMG, the difference of cubes. X times x times x is x cubed. 2 times 2 times 2 is 8. So this right here all reduces to x cubed minus 8.
Wow.
Okay. Yeah. We're just saying the derivative. dy dx is just a different way of saying derivative instead of saying y prime all the time. What's the derivative of x cubed?
3x.
All you're doing today is practicing. I could have gone and continued. See, look, we got 2 more rules. But before, guys, because of that, tomorrow during lab, we're going to have to do product and quotient rule. I hope that's okay with you guys. So all you're doing today is just practicing power rule.
See, I'd rather do that than be stressed about doing Delta tomorrow.
I mean, miss. All right. Product rule. We used to do the proof of the product rule, but we're just going to go right into it, guys. So if you have 2 things that are being multiplied, here's what this says. First times derivative of the second plus second derivative of the first. That's all it is. See? Where U is the first, the V is the second. So this is like, the U here is like x squared plus 1, and then the V here is like x cubed plus 3. So it wants the derivative of this. So I'm going to write f prime of x equals, and it says first, so I'm going to leave it alone. X squared plus 1 times the derivative of the second. The derivative of x cubed plus 3 is just what? 3x squared. Plus second, x cubed plus 3 times the derivative of the first. What's the derivative of x squared plus 1? What's the derivative of x squared plus 1? 2x. That's my derivative. And now we're just going to do algebra. I know, guys, you probably wouldn't do product rule for something as simple as this. You'd probably distribute first. But the whole point, like, don't worry. Right now we're going to do distributing. We're going to distribute with the original and see if we get the same derivative here. When I multiply here, that's going to be 3x to the 4th plus 3x squared plus, let's see, 2x to the 4th plus 6x. Combine like terms. f prime of x equals, let's see, I got a 3x to the fourth and a 2x to the fourth, so that's going to be 5x to the fourth. I got 1 3x squared, so plus 3x squared, and then I got 1 6x plus 6x. Chav, how do you know that's for sure the derivative? Well, one, I followed the product rule, this guy. But let's say we didn't know the product rule. Let's say we were to FOIL this out. X squared times x cubed, that's x to the fifth. Everyone okay so far? X squared times 3, that's 3x squared. Look, I haven't taken a derivative. I'm just distributing. 1 times x cubed, that's x cubed. 1 times 3, that's 3. Putting them in order, x to the fifth plus x cubed plus 3x squared plus 3. I haven't done anything, guys. I just wanted to prove that this is the same as this, the derivative. So let's take a derivative. I'm gonna go f prime of x. What's the derivative of x to the fifth? There you go. Look at that. It's right there. What's the derivative of x cubed? Look, it's right there. What's the derivative of 3x squared? Did we get the same thing? So there it is. That's called, what rule is this called? Product. Whenever you have two things that are being multiplied. Two functions that will respect to x. Because, okay, time out. Do I use product rule? Yeah, we got to talk about this because there's always confusion. Do I use product rule for something like this? No. I mean, you could if you wanted to. Call that the first, call that the second. First times derivative of the second plus second, the derivative of the first, and the derivative of 5 is 0. You could, but yeah, there's no reason to do that. You can just use your power rule. Does that make sense? Now, if I have something like this, 5x times, of course, you probably wouldn't do product rule anyways because you would just do the algebra first. But if you have something like that, then you would do product rule. Does that make sense? You got to have a variable. Of course, something like this simple, you probably wouldn't use product rule. It's coming up. When we start doing trig, you'll see that product rule, we're going to be using it all the time. All right, here we go. It's in the same notes from yesterday. All right, so here we go, guys. It says let y, I don't know why it came out like this. Maybe something with when I transfer to PDF, it like flattens a formula or something. Let y equals uv be the product of the functions u and v. Find y prime of 2. All right, guys, so here we go. Y equals uv. So derivative, y prime equals first, derivative of the second. I'm going to put v prime instead of dv dt, plus the second derivative of the first.
Wait, Chuck,
What's up?
do you have any more copies of this?
No. I made the exact copy number because you told me. Remember? You don't have your iPad?
I forgot. I don't know my laptop. It's fine.
I remember I had a copy yesterday after school, but I remember talking to someone and saying, hold on to it. And then, no, they didn't hold on to it. They were like, why? All right, here we go. All right, guys. Y prime evaluated at 2 equals u of 2. U of 2 is 3. V prime of 2, which is, yeah, right here. Bless you squared. Bless you to the fourth power. Bless you to the fifth power. Bless you. Oh, today's square day. Did you know, Miss Cruz? Today's square day. Yeah. 3 squared, 4 squared, 5 squared. 9, 16, 25. Wow. Okay, I'll stop. Plus 1. She wasn't impressed. She's like, okay, whatever. Times the derivative of u. U is negative 4. Right? It's this one right here. And I think I did everything correctly. 6 minus 4, so I got 2. You're going to have questions like that on your homework. Not today. Today's the delta route pout. Tomorrow when we practice. Cool or not cool? And that's it. That's product rule. All right. Here's quotient rule. I have something that's called the top, which is u, and I have something that's called the bottom, which is v. And there's a little song. Whenever you're taking the derivative, you're going to go low d high minus high d low over low low. Let me tell you what that means. Low means obviously the bottom. D high, D stands for derivative of the top, minus high, U. D low stands for the derivative of the bottom, all over low low, which is just low squared. Or you don't have to do that. You can just say bottom times root of the top. You started from the bottom, now you're here. That's how you know. So you always start from the bottom. No, for real. You started from the bottom. So say it with me. Low D high minus high D low over low low. There it is. You got it, guys. So I want the derivative of this guy. So here we go. I'm going to go f prime of x. And it says low D high. So that means low. You leave it alone with the bottom. X squared plus 1 times the derivative of the top. What's the derivative of x squared minus 1? No. 2x. Yeah. Just 2x. Minus high D low. X squared minus 1 times the derivative of the bottom, which is again 2x. All over bottom squared. Are we okay, guys? All right, you're done. You're just doing algebra now. So let's see what that is. 2x cubed plus 2x minus, and then, so don't forget that negative is going to turn to a positive right now. Minus 2x cubed plus 2x all over, and then don't expand the denominator. Just leave it as x squared plus 1 with a square on it. Are we still okay? All right. The 2x cubes cancel out or zero out. 2x plus 2x is? So my derivative is nothing more than 4x over x squared plus 1 with a square on it. How are we feeling, guys? Okay. All right. Now let's do some problems similar to what you did yesterday. Here we go, guys. Find an equation for the line tangent to the curve y equals x squared plus 3 over 2x at the point 1, 2. You don't have to do quotient rule, but since we just learned quotient rule, we'll just do quotient rule because I'm going to divide each term by 2x. But here we go. So what do I need for a tangent line? I already got the point. I need my slope. So here we go. I'm going to take a derivative to find my slope. Y prime equals bottom, low D high. Bottom times the root of the top. Yep. Minus top, x squared plus 3 times the root of the bottom. No, just 2. Just 2 because it's linear, right? All over bottom squared. Are we still okay? All right. I'm just going to do some algebra. Not crazy algebra. 2x times 2x, that's 4x squared. Minus, and then let's see, 2 times x squared, that's minus 2x squared. And then 2 times 3, that's minus 6. Don't forget, we're distributing the negative, right? All over, let's see, y square that. That's going to be 4x squared. Is everyone okay so far? All right. Y prime equals, when I combine like terms, let's see, 2x squared minus 6 over 4x squared. Are we still okay, guys? All right. What value am I going to put in for x? 1. So y prime evaluated at 1 is nothing more than 2 times 1 squared minus 6 over 4 times 1 squared. Let's see what we get. 2 minus 6, negative 4, divided by 4, negative 1. Here's my tangent line. Y minus 2 equals negative 1, parenthesis, x minus 1, close. You can leave it like that. That is perfectly acceptable. Do you guys want to see how this curve looks? Yeah, let's look at it. I'm going to go to Desmos. And I'm going to type, let's see, what am I going to type? Open graphing calculator. Give me my original equation, guys. X squared plus 3 over 2x. Okay, so there it is. And then they wanted the tangent at the point 1, 2, right? So look, there's my point. Can everyone see that point? All right, give me my tangent line. Y equals. And yeah, that definitely looks like a tangent line, guys. So make sure, check your work. Make sure it looks like a tangent, guys. So we're good. I think we're good, guys. All right. And then now here, all this means, relax. Let's see what this says. The derivative of y prime equals dy dx is called the first derivative of y. with respect to x. The first derivative may itself be a differentiable function of x. If so, y prime prime means the second derivative. It's called the second derivative of y with respect to x. If y prime prime, y double prime is differentiable, it's derivative. So that just means keeps going. So I'm going to write it here. This is y prime. This is my first derivative. First der. Y double prime is the second der. When I say der, I'm talking about derivative. Y prime 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 is the third der. Third derivative. And then after you pass the number 3, some textbooks will still have another prime, but usually they use like Roman numerals. Fourth der. And if you, oh, what's up?
What does it mean, like, second derivative? Like, is it, we take the derivative twice, or like?
You take a derivative again.
Okay.
Yeah. So, by the way, guys, this is like dy dx. Sometimes this one, they'll show it like this, d squared y over dx squared. Third derivative, d3y over dx cubed. Fourth derivative, d4y over dx to the fourth. So that's why down here, did I put it? Oh, I did not put it. Dang. So if I want the nth derivative, nth, you're going to go dny over dx to the n for the nth derivative. And then when you get to multivariable and calculus 3, they'll start doing like dx for partial derivatives or derivatives with respect to the x. Maybe you'll see a little dot, maybe for Jacobian, x with the 2 dots or physics. That means second derivative. But we'll worry about that when you guys get there. What's up, Vega?
I thought derivative was like the instantaneous rate of change.
Yeah, it is.
So then how do you find the instantaneous rate of change for the instantaneous rate? Like,
Well, if you have a position time graph and you get the first rate of change, that's going to be meters per second. So that would be like velocity. And if you get the instantaneous rate of change of the instantaneous rate of change, so that's like finding the derivative of velocity time graph, then it's going to be the change in velocity over time, which is the definition of acceleration. See? And if you get a derivative of that, then you'll have the change in acceleration divided by time, which is called a jerk, and so on and so forth. You just keep differentiating. You know what I mean? Or you don't know what I mean?
no, I don't.
Yeah, we'll get there in a little bit. All right, how do we feel, guys? Do we feel okay? All right, I Miss Cruz, focus, Miss. All right, here we go. I want the first 4 derivatives of example 12. You guys ready? I'm going to use this notation. dy dx. What's my first derivative of that? 3x squared. Yep, that's it. All right, here we go. Second derivative, d2y over dx squared. I'm gonna take a derivative. I'm taking the derivative of the derivative. Does that make sense? What's the derivative of 3x squared? Perfect. Let's go to the third one. d3y over dx cubed. What's that derivative? Yep. And if I were to do a fourth derivative, which is as much as you can do here, yeah, it zeroes out. All polynomials, all of them, will eventually zero out because you're doing the rate of change of the rate of change. So eventually it's going to be 0 if you keep going. Unless you have a spring, then it goes forever, right? Because it just bounces forever and ever and ever. Of course, due to gravity, it'll eventually will stop. But technically, a spring will go like that forever with a weight on it. How do we feel, guys? All right, then we're just practicing. So here we go. We're just going to practice. What rules do I got to use for letter A? Product. So here it is. I'm just going to write the definition first. First times derivative of the second plus second derivative of the first. Okay, here we go. First, so u, let's see, where are you? 5 times v prime. What's v prime? 2 plus v, negative 1 times u prime, negative 3. So let's see. Hopefully I didn't do anything wrong. 10 plus 3, what do we get? There it is. That's my answer. Are we okay? All right. Letter B. What rule do I got to use? Quotient. So bottom, low d high times right at the top, u prime. minus top, derivative of the bottom, v prime, all over bottom squared. All right, well, we're just doing the definition, guys. We're not doing anything. So here we go. We're just going to plug in. So v is -1. U prime is -3. Minus u is 5 times v prime 2 all over bottom squared, which is -1 squared, like that. All right, so let's see. 3 minus 10 over 1. So what's my final answer? -7. All right, be careful. It's what rule do I got to use for this one? No, it is. It's the same. It's called what? Quotient. Yeah, be careful because look, they reverse the letters on you. So bottom times derivative of the top, which is v prime. See, they reverse the letters on you. Minus top times derivative of the bottom, all over bottom squared. All right. I guess I didn't have to put parentheses because I'm just putting letters here. All right, here we go. Let's go ahead and start typing in the numbers. Bless you. So u is, was it 5? Times v prime, 2, minus v times u prime, all over u squared. All right, let's see what that is. So 10 minus 3, because negative times the negative is a positive, so it still says minus, all over 25. 7 over 25, yep. How do we feel, guys? All right, here we go. Last one, and then we'll just do a whole bunch of practice. So this says 7v minus 2u. So here we go. The derivative of 7v is just 7v prime. That's it. You just leave the 7 alone, right? Minus 2u prime. Are we okay? All right, let's see what that is. 7 times, what's v prime? 2 minus 2 times, what's u prime? All right, so 14 plus 6. What's that, 20? And there it is, guys. Does the rule make sense to you? Like how to apply it?